Welcome back to Thailand. We've got a very large thunderstorm coming over the mountain, looking for some rain. But you're not here for that. You're here for this. What the heck is this thing? Well, it's the next evolution. Let me show you. So this is version 1.4 of the PM2.5 pollution sensor. And that's going to consist of three parts: software, circuitry, and the enclosure. The enclosure is here. I got fancy on this one and actually designed a full enclosure. It's got an air in and an air out hole, which we use this screening to block dust. Well, not dust so much, but like spiders and things were crawling inside our beta test units, so this is necessary. I also changed to a USB-C jack because it actually has through hole soldering points, because the USB micro ones were just snapping off the board. And then it has two little holes that allow the LED lights to shine through for power and activity. The enclosure itself is in two parts. The bottom one actually holds the sensor in place like that. And then it's got four posts that hold the circuit board in place. And these are at the same level. So it's got support in the four corners and then around the sensor. The underside also has the sensor spot to lock that in place, and also a space for the little fan. This tiny little guy moves the most air that I found of any fan of its size, and that will help draw the air through as we take a sample. Because if we don't, then it's just going to be sluggish air that's just sitting there, and it's not going to be a valid reading. Now, in Fusion360, which I'll talk about in a minute, I could not get it to make a little tube from the hole to the in port of the fan, the out port of the fan to the in port of the sensor, the out port of the sensor to the other hole. There's a command for it in Fusion. It would not let me. It kept giving me errors. Anyway, so I've also got these little clips that allow this to snap together and apart easily. And the next cool part is the circuit board. And as you can see, it's evolved quite a bit. First of all, I completely did this in the Fusion360 schematic and circuit board facility, which used to be Eagle, but they bought Eagle and then brought it into Fusion360. And what is cool is your circuit board and your 3D design can actually be modeled in the same space, so you can check for fit and clearance, and you can take them in and out and rotate them around and see how everything's going to look. In practice, it's a very cool idea. Right now there are some integration issues in Fusion, but I expect they will be solved someday. And as you can see, the sensor actually fits through the circuit board, and it gets held in place in the bottom and the top enclosures, because there's only a few traces of the circuit that need to go around it. We've got our ESP32. We have moved to the USB-C connector here, and you can see it's got four big thick soldering tabs, power and activity LEDs. And I added two more features. Obviously, one for that drives the fan. There's a MOSFET that drives the fan, which is triggered by a digital out. There is also a MOSFET that powers on and off the sensor, so it only powers it when we need to take a reading. Then I also added the JTAG port for hardware debugging with the ESP prog board, which I showed you how all that works in another video. I will be able to use the JTAG mini connector to the mini connector on the board and use standardized ribbon cable, because the cables I'm making up myself have become very unreliable because of the way the pins just don't grab after a while here. So I will have full hardware debugging in the cable that goes between these two places. Okay, let me take you inside Fusion 360, and you can see this is the electronics design part of 360 that has been added. Now, I have migrated away from Design Spark because it was just getting no updates. The performance was really terrible, and there was some bugs that I was getting fed up with. So since I'm already a Fusion 360 3D CAD fanboy, I thought, all right, let me integrate everything together, because I do schematics, circuit boards, and 3D. This is my first project where I'm pulling everything together, and I thought, all right, let's give it a try. I bought a 1-year license for close to $500 because I want to support them, but geez, that was a big click. And as I discovered, all is not well in the world of electronics within Fusion 360, but I'm sure they'll work through them. So here's the schematic. Here's the this is the USB-C connector where I'm getting 5 volts, and all I'm asking for is 5 volts out of this, plus a very, very robust connector. By adding these 2 resistors here, it's telling the USB-C protocol that I am asking for plus 5 volts. It's magic. It's a copy and paste from some stuff I found on the internet, so don't worry about it. This is the power supply area. I take in 5 volts, I put out 3.3 volts. This is the reset switch. This is the JTAG debugging connector, which goes to very, very specific pins on the ESP32. Power supply filtering. This is the activity LED. There's a power LED over here somewhere. Yeah, it's right there. And then these are the 2 MOSFETs. This MOSFET drives the power to the fan. This MOSFET drives power to the sensor. And then this is the sensor signal out, which is a 5 volt signal, which will blow up the ESP32. So I have to use a resistor divider network to get that down to right around 3.3 volts. Now, what you do from here is when you've got your schematic ready, then you go over and you start laying out your circuit board, and it automatically maps over all of your parts and all the connections between those parts, and then it's up to you to place the parts inside your design and then lay out the traces. You can lay out the traces by hand, or it has an auto router, which I would give about a 6 out of 10 on. It's not great. It certainly produces some very ugly layouts. You can let the auto router run and pick one that's the closest to what you like, and then you can tweak it by hand, but it's still a tremendous amount of effort. It also is not smart about ground planes. So the entire back of this board that you can see in red is a ground plane. If I've got a pin, say this pin right here is a ground pin, it will not go out and drill a via down to the ground plane in a very close proximity. It will try and run a wire over to another thing that's labeled ground. I might not know where to set that up. If somebody knows how to set that up in the new Fusion 360 Electronics in here, that would be a lifesaver, because I had upon trial and error, I ended up having to just make vias on my own. Then I basically ended up hand routing the rest of the board. I got the entire board is basically only on the top, except for one little hop that goes across 2 traces right here. I could not, for the life of me, work out how to make this a single-sided board, essentially, and have the ground plane be on the bottom. Now, you can obviously see there's a giant cutout here for the sensor and JLC PCB. was able to read that correctly and make that cutout for me. The board was beautiful when it arrived. Now, when you've got your circuit board, you can ask to see a three-dimensional view of it, which is pretty sweet. And what I did was I imported some 3D packages of the USB-C connector and the ESP32 in what's called step form, but they come through translucent, and nothing I could do would make them a solid component. So let's take a look at the 3D view. This is what Fusion 360 gives you for your 3D view, and you can see this connector is translucent and the ESP32 is translucent. Although it's you know, it's good to visualize how everything is going to look. You can turn it like this and see if you have any height interferences. You can make sure that, you know, all of your pads look good. You can flip around to the back side. Well, let's bring that puppy back. You can, oh, come on. Sometimes it does very strange things like this too. Let's go. I want the back. There. So you can see your ground planes and everything, and if we zoom in, you can see where I've drilled through on a via to get to ground from the top. Now, one thing that confused me was when you ask for your 3D view, it does not bring in your silkscreen. I don't see any parts identification. I don't see anything on the silkscreen layers, which is disappointing. Kind of freaked me out until I exported the Gerbers and loaded them into a Gerber viewer out on the wild internet somewhere, and it did show me my my parts labels and my text that you can see here. So I would say this is a good validation, but it's not perfect and needs to be improved. So next thing is the enclosure. I fully modeled the enclosure. You can see it's broken up into two pieces, the bottom part and the top part, and that all looks good. There's our USB-C hole and the LED holes and the supporting. Then we can look at the top. We've got the airflow holes, and the really cool thing is I can make sure that my airflow is going straight through the hole, straight through the fan, straight through the sensor, and straight through the exit hole just by visualizing it this way. So that's pretty cool. Now, let's look at the final assembly, because it lets you pull all of your things together into one view. And as I just said, I can confirm that the air goes through the center, through the fan, through the in hole, and through the out hole, just by making sure all of those things are in alignment. I can turn off the fan and the sensor. I can turn off the circuit board. So you can turn some of these things on and off. I'll put the sensor back on. And I also uploaded this as a step file from someone who put in a tremendous amount of work to model this thing. It is just beautiful. But again, it's translucent. I don't want to see all this stuff. I just want to see the outside visually rendered. And trust me, I tried to apply different textures and materials and colors to this, and it's just treating them like a bajillion small components unto themselves. I can turn on the fan, and the fan just drops into place there. You can see the veins on the fan, so that's all very cool. I'll turn the circuit board back on, and we can see that we have clearance for the sensor to fit around the space for the enclosure. Now, I would have had to cross my fingers and guess that I had enough clearance between the sensor body and the board, but I can visually confirm it. It's a whole nother thing. It's very, very, very valuable feature. One downside is if I want to turn the bottom back on, I can't do it from here. If we click over here to bodies and I click on bottom, it says visibility cannot be changed. in the final assembly view. The only way I can do it is I go back to the enclosure, I turn the bottom back on, I save it for the bajillionth time. This thing loves to save, let me tell you. Then I come over here and it tells me my enclosure is now out of date. Thanks for telling me. Why don't you update it yourself? No, I always have to select it and then say get latest version. Or at least pop up a box to say, hey, do you want the newest version of this thing that you fixed in another window? Yeah, that would be lovely. So again, I can come over here, I can look through here, everything is good, everything is happy. And now I can go ahead and start committing things on my product. I can send this off to an injection molding company. I can send the circuit boards off for manufacture. I can buy the components because I know everything's going to fit. And then when everything shows up on my doorstep, it all goes together with no surprises. So it's very, very, very valuable integrated tool. I will give them that. It's extremely powerful, more powerful than I even know how to exploit, and it gets the job done. So let me go ahead and build up one of the circuit boards and get one of these actually running. So since I need to get the ESP32 off, the very expensive ESP32 off my version 1.3 boards, I thought I would try this trick. People use clothes irons to gently and evenly heat up the parts until they just come right off. This may be a sacrificial and I have to go with new parts, but it's already got the software loaded on it. It'd be great if I just soldered up the new board, powered it up, and it just worked perfectly. So let's see what happens. Well, that was a bust. I had it cranked up all the way on the dial, and I could hear the internal thermostat clicking on and off, and it was really hot to my hand, but not enough to melt solder. The flux was melting, but the solder was just not quite at the melting point. And I lent my temperature gun to a friend of mine with a restaurant here so he can beat people as they come in the front door. I'll have to snag that back for him and do some science and see what it will take to actually make this work. So now I'm going to have to remove it the hard way with the hot air gun. Well, the hot air worked. I hope I didn't cook it, because I heated it from the back to kind of release it, and then I heated it from the front to hopefully release the solder, and it came off. So we'll see if this guy's still alive. Okay, I'm all set up for the solder paste and my parts. So let's get this built. Well, the soldering all went very well except for the USB-C connector. I don't know if it can focus at all, but I got a short across all the pins. I think what I'll do in the future is put the solder paste on and then wipe it off on this connector and then just solder each of those pins by hand, because there's so much solder paste gets put under there. It's a natural place for a lot of short circuits. So let's power it up. And I'm under my desk at the most convenient place. I'm going to use my DJI drone USB-C adapter because I know that works. Oh, we have a power light. We don't have any smoke. Let me check Wi-Fi and see if... Oh, we have blue... Ah, we're working! It's actually taking a sample right now, which is going to fail. but the code is running. That means the ESP32 is up and running. That's pretty awesome. Now, it's retrying in an attempt to get a reading from the sensor that's not there right now. Okay, I soldered in the fan. Unfortunately, this is as much wire as we get from the factory. Typical supplier trying to save 1/10 of 1 cent. But let's plug it in. God, I love just plugging it in and it works, not flipping it over. Okay, it actually powers up on boot up. That's the state of the pin on the chip until my software takes control. And then it should spin again when I'm taking a sample. Good. Okay, I've got the sensor wired up. So hopefully it will power up, start taking a sample. It'll spin the fan. No, it'll go the blue light. There's a power up delay. Spin the blue light, spin the fan, take a sample, upload it to Wi-Fi, and then turn the blue light off, as it should have already connected to my Wi-Fi. Yes! That's exactly the time that I'm looking for. Fantastic. And there it is. It popped up on the network, exactly the same IP it had before, exactly all the same data. If I click refresh, you can see how quickly it repopulates. And if we look at the board, I click the refresh button and we see a tiny little blink of activity on the activity LED. There. Page refresh. That's awesome. So the software is 100% compatible with the new hardware. And we're going. So, just need to build the rest of the units and send them off to my beta test team. While I was getting the unit ready, I wanted to see if I could clean the sensor. Sensor's in 3 parts. Plastic part, metal shell, and this assembly, circuit board, and 2 components. One is a transmitter, one's a receiver. They go through these 2 lenses. So there's 1, 2, 3, 4 things that I'll try and clean up, maybe with a Q-tip or something, and get this back to factory spec so I can get some good fresh readings. Okay, here's what it's like in the housing. Of course, I don't have the M3 screws or the JTAG connector. They're still on a slow boat from China. So let's assemble this with the very short cable. That pops in like that. And then the whole thing closes up like that. Now let's plug in the power. It'd be easier if the board was held down. We have power. Four, 3, up. And we're taking a sample. So that's great. You can't even hear the fan, but trust me, it's doing something. So I'm almost ready to send out to the beta testers. That'll wrap it up for today. Hey, if you found this video interesting, please give it a thumbs up. And if you like my other content, I'd appreciate a subscribe. Take care and see you next time.